Today's notes are on trigonometric ratios. So what you're going to learn is finally what that sine, cosine, and tangent, what those buttons are on your calculator. Let's first define what a trig ratio is. So what we've got written here in red says a trigonometric ratio is a simplified fraction of two sides of a right triangle. All right, and our three trig functions that we're going to use are the sine, which is abbreviated on your calculator as cosine, and then we've got cosine, which is abbreviated as cos on your calculator, and then tangent. Okay, so each of these represents two sides, a ratio of two sides of your triangle. So we'll start with sine. So sine of an angle, so it's either this little acute angle or this one. It is the opposite side from whatever angle we are talking about. The opposite side over the hypotenuse. Okay, so if this is my angle right here, this would be my opposite side, and this would be my hypotenuse. For the cosine is the adjacent side to whatever angle we're talking about over the hypotenuse. So for this angle, this is the adjacent side. So adjacent means touching. And then your tangent is the opposite side of whatever angle we're talking about over the adjacent side. Okay, so we have to have the sine, cosine, of an angle, an acute angle, so we'll never be using the right angle. So this is my acute angle, this is my opposite side, this is my adjacent side, and my hypotenuse. If I change which angle I'm talking about, if I call this my angle, then my opposite side is here on the bottom and my adjacent side is on the left. So your opposite and your adjacent sides are the legs of this triangle, and which is which depends on which angle you're looking at. All right, so we're going to explore that a little bit here in example 1. Okay, so that's what this remember here says. The opposite and adjacent sides will change depending on the given acute angle, but the hypotenuse will always be opposite your right angle. So we're going to start with D. So we're right here on angle D, and we are going to label the opposite side from D, the adjacent side from D, and the hypotenuse from D. Okay, hypotenuse is actually going to be the same regardless of which angle we talk about. Let me go up here and just give you a quick abbreviation on each of these. You may have seen this before. So, ta, toa. These are just acronyms to remember which sides go with which trig function. So sine is the S, that's opposite over hypotenuse. C is for cosine, that's adjacent over hypotenuse. And then tangent is the T, that's opposite over adjacent. All right, some years back, one of the teachers came up with a sentence to remember those. So sine, cosine, tangent, you're always going to see them in that order. Even on your calculator, you've got sine first, and tangent. And she remembered the letters of those ratios as Oscar had a heap of apples. Okay, so you write them down and you memorize them in any way that works for you. Just remember that opposite over hypotenuse is with sine, adjacent hypotenuse is with cosine, and opposite and adjacent goes with tangent. All right, so you're going to see me write those little abbreviation here as I start to work on these fractions, okay, these ratios. So if we're looking from D, 7 is the opposite side, 24 is the adjacent side, and 25 is the hypotenuse. So sine opposite 7 over hypotenuse 25. Cosine adjacent 24 over hypotenuse 25. And then tangent opposite is 7 over hypotenuse, or sorry, adjacent 24. So tangent opposite over adjacent. If it was possible for you to reduce any of these fractions to be more simplified, we would do that, but that doesn't happen here in number 1. It will happen in number 2. The second part of question 1 asks us to change the angle that we're looking from. So now we're looking for sine, cosine, and tangent of E. And what that means is that 24 is now the opposite side because I've changed the angle from which I'm looking. And then 7 is the adjacent side. So when I'm looking for the sine of E, opposite is 24, and hypotenuse is 25. Adjacent side of E is 7, hypotenuse still 25. Tangent, opposite, over, adjacent, 7. Okay, let's look at number 2. So we're starting first with angle A, right here. Let's label our sides with that angle. So for A, 8 is the opposite side, 6 is the adjacent side, and 10 is always sine is opposite over hypotenuse, cosine, adjacent hypotenuse, tangent, opposite, adjacent. All right, so let's go. So sine 8 over 10, which we can reduce to 4/5. Cosine adjacent over hypotenuse. Again, we can reduce that to 3/5. And then tangent opposite over adjacent. Reduce. Okay, let's change our angle to angle B, which means our opposite and adjacent are going to change. So now we're at angle B. The opposite side there is 6, and the adjacent side is 8. So I'd like you to pause the video right now and try and do the sine, cosine, and tangent of angle B, and then reduce them, and then unpause the video when you're done. Okay, so you can see that I wrote each ratio and then I reduced it. So let me go through those quickly. So from angle B, sine opposite 6 over hypotenuse 10 reduces to 3/5. Cosine adjacent, which is 8 over hypotenuse of 10 reduces to 4/5. And then tangent opposite of 6 over adjacent of 8 reduces to 3/4. Okay, so we're going to check your calculators now and see if you've got them set up to properly do trig in your calculator, because we're going to put together what we do in 1 and 2 with number 3 on the back to be able to solve for missing pieces in any right triangle. Okay, so what I want to do is I want you to type in the tangent of 18 into your calculator. So I'm going to pull up my calculator here, and I'm going to hit the tangent button, and then I'm going to hit 18. Let me move my recorder. And then another thing I need to check here, I need to check the mode in my calculator. So next to the second key, if you've got a graphing calculator, you want to hit the mode key and then move down to the fourth row, and you need to be in degrees. So if you are not in degrees, you need to move your arrows down, move over to degree, and hit enter. All right, so let me go back to second mode to be quick. We go back to my computation screen. So in your graphing calculator, if you are not getting this same answer as I do, you need to change the mode in your calculator. Scientific calculators, you should be getting the exact same answer as I do. All right, so we're going to round this to the nearest hundredth. So that's 2 decimal places. So 0.32, let's peek at the number next to it. It's under 5, so we stay 0.32. Okay, so we'll go back here and we'll make this 0.32. All right, let's do part B and C together on the calculator. Let me move back to my calculator, and we're going to hit sine and then 52 degrees. And then we're going to hit cosine of 39 degrees. So for part B, for the sine of 52, we've got 0.78, but then our third place is 8, so this is going to have to go up to 79, 0.79. And for our cosine, 0.777 is going to make that go up to 78. So for our sine, we're going to have 0.79, and for our cosine, we're going to have 0.78. So let's write those down. 0.79 and 0.78. Okay, I want you to pause the video now, and I want you to do D, E, and F on your own, and then unpause it, and let's check our answers together. Okay, so these are the answers that you should have gotten if you correctly entered these into your calculator. So for the tangent of 29, 0.55, for the tangent of 6, 0.10, and the sine of 6.10, and then the cosine of 37 degrees, 0.80. Let me flip over to my calculator, and you can see that on the cosine of 37, you did have to round that 79 up to 80. Okay, moving on to the back where we're going to put this together. So we're going to use trig to solve for a missing side in a right triangle. So in our previous sections, we learned about our special right triangles, our 45, 45, 90, and our 30, 60, 90. What happens if one of the acute angles is not one of your specials? You have to use trig. So what's going to happen first is we're going to label the sides from the given angle. So in number 4, we have 19 degrees given. So I'm going to label the sides that we have with respect to this angle. So we have x as our opposite side, and we have 15 as our hypotenuse. Okay, so that's our first step. Let's look at number 5. So from 49 degrees, this 21 is our adjacent side. And then again, we have the hypotenuse. Let's keep going for the rest of these questions, and then we'll come back up to the next step. From 24 degrees, 6 is the opposite side, and x is the adjacent side. From 42 degrees, x is the opposite side, 16 is the adjacent side. For number 8, from 31 degrees, 9 is the opposite side, and x is the hypotenuse. And for number 9, 53 degrees is our angle, so x is the adjacent side, and 21 is the hypotenuse. Okay, so that's our first step, is to label which sides we have from the given acute angle. Next step, Decide which trig function should be used with the given sides. So again, sine is opposite and hypotenuse, cosine adjacent hypotenuse, and tangent opposite adjacent. So in example number 4, it's opposite and hypotenuse are the sides that we have. So opposite and hypotenuse are sine. So we're going to use sine of that acute angle, 19 degrees, and then we write our ratio. So our sine is our opposite side over our hypotenuse. Okay, let's write number 5. Let's set up the equation, and then we're going to solve each one. Okay, so in number 5, from our 49-degree angle, we have adjacent and hypotenuse. So adjacent and hypotenuse would be cosine. So cosine of our acute angle, 49 degrees, and then we have to set up our ratio. So adjacent is 21, that's the numerator, and then hypotenuse is x. Okay, so you have to go in the order that is given for each of these trig functions. So the difference between these two equations, in example 4, we have the x in our numerator, and in example 5, we have x in our denominator. And those are the two variations that you're going to see. And the way that we solve each one of these is different. Your goal is to solve for x, which means that you need to get x alone. So for number 4, to get x by itself, I need to get rid of that denominator of 15, so I'm going to multiply both sides by 15. So 15 times the sine of 19 degrees will be my measurement of x. All right, so we go to our calculator and we type in 15 times the sine of 19 degrees. And what we get to 2 decimal places would be 4.88. That is the measure of this opposite side from 19 degrees. So 4.88. All right, so it's easier when your variable is in the numerator than in number 5 when the variable is in the denominator. So for number 15, or for number 5, you need to get this x out of the denominator. So typically what we would do then is we would multiply both sides by x, but then you've got x here as a multiplier with the cosine of 49, and you'd need to divide by that. So a shortcut that we can do when your variable is in the denominator is we could just switch these. So x will be 21 divided by the cosine of 49 degrees. That will happen anytime we've got our variable in the denominator. Okay, we're going to end up dividing by our trig function instead of multiplying like number 4. So let's type this into the calculator, and then I'll go back and explain one more time why this shortcut of not showing that work actually is true. All right, so let's go. 21 divided by the cosine of 49 degrees. And what we get is 32.009. Let's round that up to 1. So 32.01. So x is 32.01. All right, so let me show you really quick why that worked. Because what you ended up doing is multiplying both sides by x. So these canceled. And then to get rid of the cosine of 49, you would have to divide by it. That's where this comes from. All right, let's look at examples 6 and 7. So let me write my trig functions up here again so we have that as a reference. Sine is opposite and hypotenuse, cosine adjacent hypotenuse, and tangent opposite and adjacent. So for number 6, you've got our angle, you've got opposite and adjacent. So opposite and adjacent goes with tangent. So tangent of 24 degrees equals opposite first, which is 6, over adjacent, which is x. So just like number 5, we've got that variable in the denominator. So instead of multiplying both sides and showing that work and then dividing by tangent, we do this shortcut, which is to say 6 divided by the tangent of 24 degrees. Okay, so 6 divided by the tangent of 24 is 13.48. So x is 13.48. All right, moving on to number 7. So from this 42-degree angle, it's opposite and adjacent. Opposite and adjacent is again tangent. So tangent of 42 degrees is opposite over adjacent. Okay, so our variable is in the numerator, so this is like number 4, where we are going to multiply both sides by that denominator to get x alone. So 16 times the tangent of 42 degrees is what you enter into the calculator. All right, so let's jump to that. 16 tangent of 42. And we get 14.406, which will become 41. So 14.41. So x is 14.41. All right, moving down to our last 2 questions. Again, I'll write our trig function abbreviations up here for reference. Okay, what I would like you to do right now is I would like you to set up each of the equations. Okay, so figure out if it's a sine or it's a cosine or a tangent. Write that with the angle and then write your ratio. Okay, so I want you to do that first. Pause the video, set up your equations, and then unpause to see if you wrote the correct equations. Pause the video now. Okay, in red, you can see the equation written for number 8 and for number 9. So check to see that you set that up correctly. On number 8, from that 31-degree angle, you are given the opposite side and you are looking for the hypotenuse. Opposite and hypotenuse are sine. For number 9, from this 53-degree angle, we are looking for the adjacent side when we are given the hypotenuse. So the A and the H of the adjacent and the hypotenuse are cosine. So we set that up as cosine of 53 degrees, adjacent in the numerator, which is x, over the hypotenuse, which is 21. Okay, so if your equations are set up correctly, you can go ahead and solve each one of these. If you need to make an adjustment, go ahead and make the adjustment. I'm going to pause the video again, and I want you to do the same, and then I want you to solve each one of these rounding correctly. Do not unpause the video until you have an answer for both. Okay, let's check your answers and see how you did. For number 8, your variable was in the denominator, so our shortcut was to switch the trig function and the x so that x was alone. So you're doing 9 divided by the sine of 31. For number 9, your variable was in the numerator, so we need to multiply both sides by 21 in order to get x by itself. And that answer is 12.64. Let me move to the calculator so you can see each one of those. For number 8, the 9 divided by the sine of 31, we did not have to round that decimal, 0.47, because our third decimal place was a 4. But for number 9, we had 0.638, which brought that up to 0.64. Okay, so that is it for our trig ratios. Go ahead and get started on your homework and reach out if you have any questions. Take care.